There we go, baby boys.
One of my most successful videos on this channel so far compares functional and object-oriented programming. This is an interesting topic, and clearly not just to me. But there's more to this debate than we discussed in that episode. This is one of those debates that, to be honest, seems a little weird to me.
I think I could have agreed with this take not too long ago. Real talk, I really do think I would be on the this is a strange debate kind of talk. Maybe if you would have asked me 5 years ago, 7 years ago, hey, Prime, what do you think on the functional versus non-functional debate? I'd probably have some stupid-ass take, right? This was probably during the height, maybe if you went 8 years ago, my height of loving RxJS, and I'd have been like, reactive functional programming is so great, right? But I really don't even know what functional programming is at that point. Still don't even really know what it is. I'm just going to be straight up here. Procedural programming is greater than everything else.
My stance is not that I hate functional programming and love OO, or vice versa, but rather that I think of each of these approaches as tools, rather than things to go to war about.
I'm not even... So this whole idea of saying that a language paradigm is a tool is an interesting take to begin with, right? Because is it a tool, or is one objectively better than the other? Because they're both an equalizer, if you will. They both simply take a problem and give you a way to solve things. So it'd be kind of silly to say that it's just a tool when, unless if there's like specific problems that lend itself better to one than the other. Oh, hold on one second. My wife brought me yerba mate and this shot full of, do you see that? You know what that is? Olive oil. And what else? She doesn't want to say what else is in here. My guess is anabolic steroids. Ah! Oh, you handed it to me. Oh, my mouth is burning. All right, now that we got those anabolic steroids, I'm ready. All right, here we go. Let's go. Eject. All right.
What are the arguments for and against OO and FP?
Okay, I like the framing. Oh, I think this is too loud. I think that's way too loud.
Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. And if you haven't been here before, please do hit subscribe. And if you enjoy the content today, hit like as well. Okay. There is no OO is best or FP is best for me. There are times when functional programming is the best choice for some things and times when object orientation is best for others.
By the way, I've never liked the term object orientation. It's not a real term, object oriented. But people say that, dude, that was like the most common phrase I hear all the time, object orientation. There's no orientation, okay? That's the wrong word. That's speaking about the positioning of items relative to others versus oriented is like that something is leaning towards or going towards it. Anyways, I could agree with this take so far. Okay, me and this Dave guy, maybe we agree. I think that my guess is that there are some problems that are just naturally easier for functional programming, and there's some problems that are naturally easier for OO. Though I'm not sure yet.
Most of the systems that I can remember building had some aspects of both approaches, despite the fact that I mostly still think of myself as primarily an OO programmer. This is not because of language support, but because OO ideas or functional ideas made most sense in the context of the code that we were writing at that time.
Is Rust a functional programming language or is it a object-oriented programming language? If you don't have the word inherits, but you do have interfaces, both, I like whatever Rust is. Multi-paradigm, because you got like this functional kind of feel to it, but you can also, is adding methods considered functional programming? Or is that just simply a feature of the language and it's neither functional nor object-oriented? I can't really tell. This is the part of the definitions that I always get confused on. Really? You think that adding functions to a struct is object-oriented? It's like, at what point does your orientation become objective? Like, where's the line? I guess maybe we should make sure we all agree on that. What's the line? To me, that's more procedural, right? Ampersand self would be the line. Message passing. Oh, we can't talk about message passing again, okay? No. My man said objective. Objective orientation programming.
I was an OO programmer in C for a long time, and some of my C code was passing around pointers to functions that I could call polymorphically, and using immutable data structures. So my C code was both OO and functional.
So again, is having a function in which you can use polymorphically, is that OO? I think that's one thing that I think we all really struggle on is the definition, a clear definition of OO. Does anyone have like a link or something that makes a clear objective definition that we could potentially agree on? Because I feel like this is going to be a very hard thing to watch without that. You know what I mean? Wikipedia, nope, F you guys, never mind.
Before I get much further in this, let me just thank our sponsors. We're extremely fortunate to be sponsored by Equal Experts, Tricentis, Transfic, and Roost. All of these companies offer products and services that are well aligned with the topics that we discuss on this channel every week. So if you're looking for excellence in continuous delivery and software engineering, then click on the links in the description below to check them out.
The
difference between OO and FP is one of those debates, though, that seems to polarize people. We can end up trying to score points in an argument rather than just shedding much light if we're not careful. The first thing to say may be obvious, but general purpose programming languages are general purpose, in that you can write any system in any language. There is nothing that you can do in an OO language that you can't do in a functional language, and vice versa. And that's really what...
Yeah, I guess if we're talking about, like, in the end, if we're talking about... If we're talking about, like, the problem, the end state, right? Treating the program as a black box, then yes, this is correct. But I mean, I think back to, like, my Java 1.5 days, you couldn't do curring. It was just like, it's a concept unavailable in that language, right? They didn't even have closures. So it was like, you could not do it. I mean, you could do something maybe like it with some sort of weird decorator pattern and try to, like, wrap that crap on top and on top and on top and on top, maybe. But you couldn't really... The rest of it didn't quite, there was no transferable concept between the two. But I assume he means at the
general
end,
purpose means,
right?
There's a difference between a general purpose language and a domain-specific language. Domain-specific languages have, by design, a narrower focus on whatever it is that their domain is. For example, SQL is a good example of a DSL, and it's great at finding a collection of records in a set, but it'd be a rather poor choice for writing Space Invaders. This doesn't mean that every general purpose...
You should never say it's a rather poor choice to write Space Invaders. I all of a sudden believe that we will be seeing sequel Space Invaders. Like, for whatever reason, when you announce something to the world that it can be done, squeal gets done, right? It just happens. It just happens. Challenge accepted. I know people just write these dumb things. I mean, right now we're writing the Chad stack for this exact reason.
It is always an equally good choice for any problem, but it does mean that any general purpose language could be used to solve any problem. In computer science, this is the idea of Turing completeness, which describes the universality of computation. It may be a bad idea to write an operating system in Python, but we could. So while it may be easier to write immutable code and pass functions as arguments in Haskell, we can write code that has the same effect in C, Java, or any other general purpose language too. While it may be more difficult to write code with side effects in Clojure or Haskell, we can still do that if we try hard enough. So the real difference between these different paradigms is not that what they allow us to do, but how easy they make it to do the things that we want to do.
It's an interesting point in what she's trying to make, which is, yeah, he's coming from it from a practical sense. I guess the first thing I always think of, which is these type of paradigms strongly dictate how you structure your code. And also the performance of your code can be very much so dictated by the language you're using. I don't know, interesting.
This is about syntax more than capability. But syntax matters. It can change how we think about the problem that we're trying to solve. Different languages...
So syntax, okay, so this isn't fair per se. It's not syntax that really changes how we do it. It's the semantics of it. So the semantic analyzer, the back end to a compiler, right? Like what it allows you to do. Because, I mean, theoretically, is there any difference between declaring a trait in Rust and an interface in TypeScript? No. I mean, syntax-wise, there's some various lettering differences, and you can use, say, semicolons versus commas, but semantically, they mean very, very different things, and what you can do with them semantically are very, very different. And I think that's like the kicker. that makes something better or worse. Is what is the semantics of it all?
And different paradigms make some ideas easier to express. That's it, really. Let's look at a really simple example. A popular idea from functional programming is the idea of mapping, as in map and reduce. In this context, a map is a higher order function that means apply some function to each element in a collection.
Which one do you like out of these two? Press 1 in the chat if you like the top one. Press 2 in the chat if you like the bottom one. 1, 2. 1, 2. 1, 2. Three. Real talk. I like this one better than that one. This one just feels like you're being a tryhard. You're just tryharding so hard to do this one.
Often seen as one of the preferred ways to process
Such
lists.
a tryhard.
One way in which map is deemed to be better is in terms of performance. Now, the real answer to whether maps process lists faster than loops is it depends.
Wait, what? What did I just hear? Did I just hear something about maps and loops being faster than one versus the other? I mean, shouldn't they really be the How would they be any different when compiled? Like, how would this be any different than that? That is like two loops. No, because it's a stream. So I assume a stream is going to be a poll model. So for each is a poll model. So this would be an iterator. So this would be, yeah. So this isn't, I assume this is effectively a poll model iterator. And so you're polling each value. So the stream would emit one value, you'd map it over, then you'd print it out. Then you'd poll a value, map it, stream, for each it. It's not doing two loops. That's JavaScript. See, with JavaScript, you do two loops there.
Depends on a lot of things. One of the common advantages cited for functional programming is that it makes concurrency easier. This is true. Writing immutable pure functions means that we can automatically parallelize them. But why is that a good idea? The naive assumption is that parallelizing like this means that we'll get the results faster. But this is almost never the case if you measure it. The problem here is that concurrency is fine.
Okay, so what just he said right then and there, that is an extremely difficult statement to qualify. Saying that we think parallelism will make something faster, but I believe he said something along the lines of in most cases it doesn't. Let me just pull that back up just to make sure I'm not putting words in his mouth.
It depends on a lot of things. One of the common advantages of functions means that we can automatically parallelize them. But why is that a good idea? The naive assumption is that parallelizing like this means that we'll get the results faster. But this is almost never the case if you measure.
So almost never the case. That's kind of a bold statement. It's a pretty dang bold statement to make that it's almost never the case. I think the more appropriate term would be is the parallelization of code and the efforts around it, any mutexes, any things that you have to add, is the overhead of that outweighing the parallelization of itself. Most problems you can do is you can break up an array to process, right? So you just turn it into a paralleled algorithm, and that's way faster. I think it just totally depends. That's like a problem domain thing. It's a very bold statement to say that it almost never matters. I would say that it almost always matters, but you may not get the bang for your buck, right? You may get a 10% increase. Everyone uses concurrency and parallelism interchangeably. Yeah, they shouldn't. Concurrency and parallelism aren't the same thing. Parallelism means two pieces of code are executing at the same time. Concurrency is more like the interweaving of many tasks, right? And people kind of goof that up. And so if you make 5 requests out to a server, you can make them concurrently. It doesn't mean you're processing the incoming responses in parallel. You're processing them one at a time. They just happen to be all running at the same time. That's kind of like the general one that people goof up when they say parallel versus concurrent.
Measure it. The problem here is that concurrency is fine, but it only improves performance when we don't need to join the results back together again. As soon as we need to rejoin the results, the costs of locks, semaphores, cache misses, and even the most efficient mechanism of all to manage that kind of concurrent join, compare and swap operations dominates performance.
It's not true at all. Not true at all. You could get so many more things out of it. It depends on what you mean by joining in all of this stuff. Again, these blanket statements are extremely hard to prove. I would just take this section as parallelism is hard And if you're going to do it, learn how to be good at it. And learn also how to measure.
Compare and swap is often hundreds of times slower than a single thread, for example. So you need 100 threads to get the same performance as a single thread, and then your concurrency problems would be worse. So map can be great for splitting problems into parallel processes, but will always be much slower if you need to rejoin the data again to look at it.
Again, careful saying words such as these. I don't know. Whenever someone says it's 100x slower, therefore you'll need 100 more. Again, careful. When it comes to performance, my general rule of thumb is that it's the same thing as when people ask me how to measure a task. I say, hey, this task is going to take me days, weeks, months, years. And because I'm not giving anything specific, I'm just giving you a range. So if someone says this thing is faster, hey, this thing can be a lot faster, this thing can be a lot slower, I'll just say, yeah, it's like it could be faster. It's like an order of magnitude faster, right? It's either like fast as shit or probably faster or somewhat equal, right? Don't ever give precise wording because you can be proven wrong in so many different edge cases, blah, 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 blah.
So if you don't gain in performance, what are the other benefits? Is the solution simpler or easier to read? I think this is a matter of taste, but I confess I don't really care very much. I see no real advantage in either representation here. As an old school programmer, I probably prefer the explicit nature of the loops a little bit, but it really doesn't really make that much difference to me. The verbose nature of Java in this example certainly doesn't show the map in its best light here. As a result of that, I thought I'd write it in Python instead. And I have to show you this little quirk because it's funny. You can't call print from a lambda in Python, so you end up doing this instead, which is certainly worse than the loop. More technically though.
Can't call print from a lambda. I don't do enough Python, but that's funny. Right, that's kind of funny.
Functional programmers and OO programmers talk about the value of different ideas, each picked to show off the advantages of their preferred approach usually. OO programmers talk about the value of modeling the problem. I value the high
modeling the problem, holy cow. Again, when Casey and I talked about this, these whiteboard programmers modeling problems, to hell with that. It's always bullshit. It's almost always universally bullshit. I'd say the only time that it's really useful to model your own problems ahead of time like this and to try to guess how your shapes and everything should be really always comes down to you kind of learning how to program well. And there just comes this point where that exercise is futile because one, you'll never know all the conditions, and two, requirements change. And so any amount of time spent other than really high level whiteboard stuff doesn't make any sense. Proof of concept faster than whiteboard. Yeah, most people, you should be able to proof of concept faster than proof of concept. Learning from it and building the final product will always be faster than whiteboarding, building it off the whiteboard, discovering why you're wrong, rebuilding it, going back to the whiteboard to fix your problems, and then building the final product. UML diagrams are full of shit. 100%. 100%. Anyone that tells you otherwise, I would be very careful digesting their opinion. Take a moment and really, you can challenge this. Okay, I am not the end all of programmers. I could be wrong. But currently, that is bullshit. Okay? Hard bullshit. Okay?
Level navigability of the problem that I get from OO. That's true. But this modeling isn't only the province of object orientation. There's a good presentation from Marco
Orientation. There it is
about
again.
A functional approach to domain-driven design that I particularly enjoyed. I liked Marco's idea that the core domain of the system is functional and the I/O.
I do like his idea, but these spaces right here made me completely discredit everything he has to say because I am a nitpicky son of a bitch right there. When I see you put little spaces in between your arguments, I just immediately, I just can't trust anything you got to say.
The edges is always not because it has side effects. After I've stored something in a file or a database, which is shared mutable state, I really want the state to have changed. This is an interesting insight and certainly bears some relationship to how I usually design systems, even though, as I've said before, I think of my approach as more object-oriented than functional. Definitions of OO usually include abstraction, which allows us to hide unnecessary details, inheritance.
I don't like that word, okay? I'm a 1D programmer. I like one level of abstraction. Anytime you're working with an abstraction of abstractions, it becomes this insanity to refactor. The moment you need to change something, you have to change so many fundamental assumptions. Wow, that's not even assumptions about what you've done. And it just like blows things up. I find that abstractions, though they look nice in their end product, like, you tell me this does not feel good. When you come up with an abstraction that when you write it out in like its final line, it's like one line of code and you're like, dot, do that, dot, done that. Boom, look at how good I am. You feel it so smooth. And then somebody comes along and is like, I need to add one. And you're just like, my life, I hate myself and I hate everything here and I'm going to quit my job, right? Like, it's just like, you somehow ruin your life over like the simplest request because you think you have something great and then all of a sudden you're completely wrong because your abstraction just slightly changes and now you're refactoring an abstraction that's built on an abstraction that's built on an abstraction and your whole life crumbles. I hate it.
Defining one type of thing in terms of another, polymorphism, being able to access things of different types through the same interface, and encapsulation, which allows us to hide.
Polymorphism isn't just an OO principle, right? I mean, polymorphism in some sense exists in functional, right? I mean, isn't that just a trait at this point? You're just treating an object with the ability to, you have X different types, but they all have a singular way in which you can access something about it. Is that really, polymorphism is kind of like everything? Yeah. Okay, because people use this term sometimes like as if it's an OO specific technique. It's just like, well, just because some got a function on it, don't mean it gotta be OO, baby.
Uninteresting detail. I think that most functional programmers would agree that all of these are good things.
Encapsulation is also not really a specifically OO idea. It's just making it so that there's some data that's grabbable or some state that's captured in something, right? Even like just a plain old struct that has some private members and some functions. I mean, is that OO or is that just encapsulation? Again, these terms are very vague and they're very hard for me to understand.
In fact, all of these are principles that also underpin functional programming. It's just that we describe those things in somewhat different terms.
There you go.
Functional programmers talk about declarative programming, which is really a form of abstraction and information hiding, and the use of types, which is based on the idea of polymorphism. Inheritance, though, is tricky because while it is clearly true that it has some strong benefits, it's also often been misused and can have some serious...
I'd say that your argument for inheritance being clearly good really comes down to I can think of right now, I still have this just one use case that I think it's good, and that's it. And I know there's other ones like it, but it's a very rare problem set. Yeah, composition's not even on here. Anyways, the only time I can think OO is really, or the inheritance specifically is really good, is when you have a method that's directly tied to a property that's needed, but you don't want to implement or state that property. So I can think about right away. I think something that's really great here. Hold on. I know where this is COBOL. Look at that COBOL. By the way, you know what I'm talking about. Me personally, do I have something that ends with TS? Do I have anything? There you go. I'll go to this guy. Something that really makes me happy, I think, in general, is extends event emitter. Right. It's just one of those things that I find to be a fine abstraction for OO, and I'm not particularly sure how you do this in Rust without, say, a macro. Right? So if you're using a macro, it kind of sucks to do, I'm not loving the macro approach here for this specific thing. And so this is one of those few items that I'm fine with being here, because then you can just do that, blah, blah, blah. And now my rectangle has a dot on and emit. No, a trait, traits only work. You can only have default implementations on a trait if the thing, again, event emitter requires a property to be present. Right, it requires something. So you'd have to make a trait and then a blanket implementation off of a couple traits. Then you could do it. But that would require you to still implement a trait per type. You know what I mean? I've never saw the diamond problem in a real code base. You haven't been programming long enough, son.
There's drawbacks. If you create
Virtual
a new window or button
inheritance.
on your display,
Baby.
it's through inheritance that you can resize or click it. Object orientation was the technical
It's not technically true.
step that really liberated code sharing. And it's no surprise that OO and the GUI came from the same place, Xerox PARC.
It's pronounced GUI. Okay. It's not pronounced GUI. Okay, we all call it a GUI. Everyone knows it. I know it. You know it.
The GUI is deeply an object-oriented inspired idea. When non-OO programmers poke fun at OO, though, they're often poking fun primarily at inheritance. That's because you can make horrible messes with inheritance. To the extent that people who prefer simple binary answers to things will often say inheritance is bad. Of course, inheritance isn't bad. But bad inheritance...
I'd say inheritance generally is bad. I'm so confident in that. We're going to go on Twitter where people are going to get angry. Inheritance is generally bad. Tweet. Send now. Suck it. I don't even know what Jack Ford said, but I'm just going to like it because that's the person that I am. Okay? That's who I am.
Is certainly bad. The big mistake in inheritance, and I'd probably say programming in general, is not to model the problem that you're trying to solve well enough. Tactical programming is often at risk.
That's a no true Scotsman thing, right? I guess you could use inheritance to model any problem. It can totally be done. All right, I get it. You can solve any problem with inheritance. It's not like it's an incapable problem. It's just how does it scale is the real question. And the fact that you have to just sit down and try to write out on paper your problem regularly to try to understand how to make changes in the system or to be able to model it in general, to me just immediately says that there's something fundamentally wrong here. Because it's not tied directly to programming in the real world, which often is messy and way harder. And then you have to keep doing this back and forth. Like I find that when I'm doing really strong OO inheritance style things, I actually am thinking on paper. I actually do draw out things because that's the only way for my small pea brain to understand the shape and the size. Whereas when I do it more just like as a series of functions and some strategic objects here and there and maybe some caching for some fast stuff every now and then, so some classes here and there, then yeah, then I don't need to model anything else out. Like I can just blaze through the program, and then the spots that suck, the spots that are kind of a bit convoluted, they usually always start off as a utils folder, right? It's just like, hey, here's a bunch of shit, I don't know where to put them. Start doing that. And once I start seeing a pattern or some things that are really needed, I'm like, you know what? Like this thing right here, I need to move over here and make it a first-class citizen because it's just really needed. Yeah, it sucks to refactor, but it generally makes it so that I know kind of what I want and how to use it. I don't know. This whole idea that this whole modeling plan is crazy to me.
Of being tactical crap. For example, in Java, a set inherits from a vector, and properties inherit from hash tables. This is tactical crap. A set isn't a vector. Properties are not hash tables. This was a lazy choice because it made implementing sets and properties easier. But
I mean, to be completely fair, a set, you can imagine that it is a vector underneath the hood, right? A set, that's really all a set is. It's either an array, which you have to double the size of and copy everything over, or it's a vector. Either way, it's kind of like the same thing. Are you getting anything out of it? I mean, I can understand why they did that. I just don't like the whole idea of inheritance. Just use a vector.
It is nonsense, really. A set is not a vector and results in all sorts of features of sets in Java that make no sense at all. What does index of an entry mean for a set?
Yeah.
Or why would I ever wish to rehash my properties? This isn't the fault of inheritance.
Why do you think you can rehash properties? Is there any reason other than it actually is just purely due to inheritance? If that's the case, that's just crazy. You should have just used a vector, not inherited from a vector. I don't know. Sets are sometimes. Sets are often, sets, let's see. A set is typically represented by some contiguous chunk of memory somewhere. And that's usually on the heap. And you put that crap in there by performing a hash set. And then if there's a collision, you may have a linked list, or you may have quadratic/linear backoff. But I think the big thing is now it's all about, they can be B-trees too, but I think the big thing is now it's all about doing linked lists in those spots.
Per se, this
Heaps
is just
are
poor
great.
tactical design choice. And we can certainly make poor design choices in any language, even functional languages. I think that the key decisions in software are outside the technical detail of individual languages largely. Or programming language paradigms for that matter. If you'd like to see what I mean, take a look at my training course, Better Software Faster. It describes what it takes to build high quality software and why that matters. There's a link in the description below. In Marco's presentation, he quotes functional programmers saying, functional programming is great because it has immutable data structures, a stateless programming model, pure functions, and no loops. These things make it easier to read.
I don't really care for immutable data structures. I don't think these really offer a huge benefit. I think they do hurt performance. If you're having to make a copy to make a change, it's not that great from memory. Just is what it is.
Reason about your code, they say. Well, in most OO languages, I can easily make immutable data structures, program stateless code, create pure functions, and avoid loops if I.
Can you make stateless code in OO? Can you? Copy on write, going, yeah, I don't know how I feel about some of those things. I mean, I like the idea, but I also don't like the idea.
Choose to, even before choosing to use the functional features that have been added to most modern OO languages these days. The real value in a more functional approach to programming, as I perceive it, is really in three areas: treating functions as variables, immutability, and declarative programming. Functions as variables is a significant step. Once again, you don't need a functional language to do this, though. I used to do versions of this in assembler, C, C++, Java, and Python. But having direct language support certainly makes it nicer to use. This allows us to pass one function as an argument to another, which can then call that function.
Yeah.
If you have ever come across two very similar bits of
first
code
class function,
that are just slightly different, like this, then this ability to pass a function as an argument is a real...
Okay, so this is something that people say all the time, and I think it's just very difficult for people to understand. And I think everyone has their own version of this, right? Because people call React a declarative programming language. But fundamentally, when you start calling any of these hooks and things like that, you're like, you start falling off the declaring nature, and you start falling into this procedural business, and then you start putting things together. Oh, I'm going to keep calling it a framework. I do declare, and it's very funny that people say these phrases because, for calling it for calling it a declarative programming language, I've seen a lot of, ternaries saying which type to use, and all this feels a little procedural sometimes, being smashed into declarative programming.
Variables is a significant step. Once again, you don't need a functional language to do this, though.
Just saying,
I used to do versions of this in assembler, C, C++, Java, and Python. But having direct language support certainly makes it nicer to use. This allows us to pass one function as an argument to another, which can then call that function. If you have ever come across two very similar bits of code, but that are just slightly different, like this, then this ability to pass a function as an argument is a really nice tool to use to simplify and generalize the code. This is also the idea behind things like event handlers. Oh, hang on, isn't that an OO idea? Immutability is an important tool, but it's never the only tool.
Is event handling a OO idea? It is? How the hell does a Berkeley socket work then? If only there was some sort of event that happened and then you had to do something with that. Gosh. If only there was something out there that was some sort of signal, perhaps, from somewhere to let you know that something else was ready. Yeah, you're probably right. It's probably an OO concept. Definitely an OO concept. Has nothing to do with anything else. You're right.
At some point, you want to change things, because otherwise, what's the point of your
Berkeley,
code?
your socket.
This is one reason why I liked Marco's point, that IO at the end of your system always has side effects. Because if it didn't, your code isn't doing anything. I agree.
Thank you. How do hardware interrupts work? I don't know. Kind of sounds like an event and a handler. Oh, you have an interrupt that exists with this? Can I hand you a function? Okay, that's not an event handler. That's an interrupt handler. They're different. See, that one's imperative programming. But when you call it an event handler, it's only OOP. This concept is just the same concept that's been around forever. Shut up.
But it's also never the whole answer, at least in the purest sense of no mutable state. At the level of whole systems, there are very few corner cases where genuinely stateless systems make any sense. And then, only in very narrow contexts where code is acting as some kind of pipe that changes the data in some way. This idea is extremely valuable as part of a system, a simplifying step. But in whole systems, there's always state changing somewhere. So the idea...
The tool I'm writing right now is this. It's literally just something that gets data from up to 6 separate data sources, puts them together, does some calculations on top of it, deep log inspections, and shits out answers. That's all it does, right? And it's stateless. There is no state. You can mock the data, meaning that I can make it so that when it tries to do these calls out to these different data sources, I can pre-provide values for those such that it's none the wiser. But nonetheless, it is just a stateless data processing tool. A lot of dev tools tend to be more stateless processing tools. You know what I mean? They just take in stuff and take out stuff.
The idea of stateless systems is never an absolute.
That's more of a dev tool item,
where
though.
you deal with the state changes rather than eliminating them altogether. Minimizing side effects is great in the right place and has been, with hindsight, an important aspect of my own approach to object-oriented design for a very long time. As Michael Feathers said to me in our chat a few months ago, object-oriented programming looks a lot like functional programming when it's done right. But whether you are
Sometimes I feel like I haven't had enough functional programming knowledge to really understand that last statement. Because when someone says when it's done right, it will look like functional programming, is that true? I don't know. I don't know how to qualify that statement. I think I'm just stupid sometimes. Because I don't know how to argue against that statement because I don't know, because I've never been able to make it into functional programming. Therefore, my self doesn't see how that's possible. I don't know where he's going with this.
developing in object-oriented fashion or functional, there are times when you want side effects. We've already talked about the obvious times when you're doing I/O of some kind. If you want to write to a file, the state that the file is in matters. Sure, you can clone an immutable snapshot of a picture of that file, but immediately you do that, it is, at least potentially, out of date, because the real file on the disk is shared. Maybe someone else changed the file, or the operating system deleted it while you were in the process of dealing with your copy. Now your immutable snapshot copy of the file is wrong. The change in the file...
I've never ran into that problem. You know what I mean? You know what I mean? I've never really had this problem of what he's talking about. I think a better example is databases, right? You try to read something from a database, you display it, but by the time you display it, happens all the time on Twitter. Someone's deleted the tweet you're trying to like, and it's like, sorry, that tweet has been deleted. I mean, I get that. That makes sense. Is that a problem? I don't know. Isn't that just the definition of a chaotic system?
File or in the database is always a side effect for another reason too. It's a side effect of working with computers that forget things when we turn them off. If I change the balance in my account, the fact that I need to store that change somewhere isn't my goal. The change in the balance is my goal, so the storage is just a side effect. Functional programming languages, of course, support this kind of thing, and some support ideas like monads that allow us to break the pure functions rule of functional programming by adding side effects. But I'd argue that this is only a special case of a more general idea. One of my favourite architectural approaches is to build message-based reactive systems. These things are like stateful actors, communicating only via asynchronous messages. One reason that I like these systems quite so much is that they allow me to separate the accidental complexity and the essential complexity in my system.
Is this a subtle support for RxJS? Signals? Do we have some other hot buzzwords that we can throw in here? Hooks? Is this hooks?
Let's imagine I have a bank account of some kind and I want to credit it. In my favourite actor-based approach, I may send a credit message with the value that I want to add. My infrastructure will manage the I/O. It will save the message on its way to my service, and only if the message is safely stored or clustered or whatever else will it forward it then to my service. At this point, my service will update the value of the account that it holds to create a new total balance. Is this mutable state or not? Is this OO or not? I'd say that this is a very OO way of thinking and working. My actors embody rich stateful domain models of the...
I would say this is neither functional or OO. This is just modeling a complex system. Right? These are each individual pieces of a larger complex system that all fit together in their whatever. Right? I mean, you could imagine this is some sort of SNS system going on here in Amazon, and, you know, or SQS. I always forget which one's which at this point. I haven't done it in so long. And it's just like a series of shit that happens. I don't know how this is either or, right? This is just a thing. It's a state machine.
Here, my side effects, the storage, are isolated.
It's SQS, effectively SQS state machine land.
Functional systems. And the change in state, an important one that must be represented somewhere, is clearly expressed and easy to understand, and can't happen without the side effects.
Hell yeah! You see all those numbers going up? Okay.
After all, I don't want my
Give me
€100
that Amazon
to
Twitch
disappear,
Prime, baby.
and I want to know that my total is even after a crash or a restart. If I want to know what the balance is for my account, I can query this stateful copy. But I can also discard this copy and recreate it into exactly the same state as before by replaying the messages that I stored. But I can also discard this copy and recreate it in exactly the same state as before by replaying the message that I stored earlier. I can also it into exactly the same state as before by replaying the messages that I stored. But I can also discard this copy and recreate it in exactly the same state as before by replaying the message that I stored earlier. So once again, is this state here mutable or not? Actually, I think it's kind of both. My point here is not to sing the praises of reactive systems, well, maybe just a bit, but to point out that the line between object orientation and functional programming, and maybe even actors, is all a bit more blurry than the culture wars would sometimes suggest. Yes, it is sensible to...
It's very hard for me to follow this example being an overarching, like he's talking about systems interacting with other systems here. I am unsure if at any point you can say you can dictate functional or object orienting. Oh, dang it. Now he got me going with this whole orientation business. You can't say it's either or because you're only looking at like, you know, the HTML of it or the HTTP of it, a series of transactions that are happening between many systems, right? There's just a protocol between them, whatever the protocol is. Now, this could be all in the same system. This could be all one language, one system, or it could be something else. Dude, I know I'm getting orientationed.
Minimize side effects in your code, whatever the nature of your code. But is there really a big difference between having a function that takes two arguments, one of them supplied by another function that defines its value, and an object with a private member variable that is used instead of the function supplied variable? Sure, the OO code here is more verbose, but that's a different question really. All that's really going on here is how we decide to represent the sequencing of the function calls.
Hold on, let's go back and look at this code for a quick second. I mean, I see what he's trying to say here. This whole idea of just creating something new to calculate this one thing, that just seems like crazy talk, right? Like, why would you do this versus that? It makes no sense. You just use a function, right? Why would you create an object just to hand it in a variable and then a second variable to get the result out to do the result, right? It makes no sense. This is nonsensical code, right? You're adding just so much complexity for no apparent reason. It's just a function. Just throw that crap on the stack and add some values or whatever you're doing.
Sure, the OO code here is more verbose, but that's a different question really. All that's really going on here is how we decide to represent the sequencing of the function calls. We could debate which one's easier to read, and there are arguments on both sides. But I do believe that if we're...
I don't think there's an argument on the other side for that one. Like, I'd have to see a more complete example to understand if there's an argument on the other side.
To minimize typing, we're already looking in the wrong place. There isn't an awful lot of typing in assembler programs after all. Optimizing for thinking is much more important. My point here is not to rubbish functional programming.
You know, as a programmer, people always say this take, which is like, oh, I spend most of my time thinking. What are you doing in your life? I spend most of my time trying to get my thoughts out of my head into the editor. That is by far the greatest majority of time I spend every week, is getting what's up in here through here.
My point is that I think that the debate...
I got to meet somebody that spends more time just thinking. Like, what the hell are you thinking about? When I hear that, I think of someone who doesn't really know how programming works. And I don't mean that in like a pejorative sense, right? Like, you're just not familiar with the concept, say, of some good async programming. And so you sit there and like look at your program trying to suss out why it's not working. Versus once you've gotten past that point and you just understand how programming works, you just make fewer of those types of bugs, and you spend more time just like trying to get what's in here through here. And I really do hope, yeah, like if you're making a fine tuning to a legacy system, then yeah, you spend most of your time just trying to understand the system. And I would agree that that's like a completely different function. But once you're implementing something, once you've understood the system, you fall back into this, I just got to get what's in here into here. But, you know, legacy systems, that is a large part of a lot of people's lives. So maybe, yeah, that's different. I work in mostly greenfield stuff. And so I think that that's like a huge problem for me. It's because due to my working in mostly greenfield, I don't have like a strong understanding of what working in a really legacy system is like anymore. But I guess I just did that recently. I just worked in a 12-year-old C++ application, and I built my own sync player to be able to effectively take in sound and video and pretend like it's playing so we could do some performance analysis of our playing tools. And so I had to build out that. And so that was all just like me typing in a completely legacy system and adding stuff. And I don't know, it just seemed, I wasn't bound by thinking. There was like a small part That was me learning what the system needs, what the values were, how to get them in place, the expected API. Then the rest of the time was me making the thing, which was almost purely a bounded me being too stupid thing, going like, oh, I got to tell you, okay, I'm doing this, and I got to get this thing out, get this thing out. And then there were some times where I was just like, the person that I said earlier, the non-pejorative thing. I don't understand C++ that well, so I was using some things wrong, and I had to re-understand why they were wrong, right? Working with sound and videos, that's fun. With sound and videos, fun, yeah, I would love the day where I could do a lot of, the day I can do faster input, I'm willing to do it. It's still a reason why I don't think AI is there, because I'm massively faster than AI. Massively faster than AI. Because the problem about AI is what it produces other than boilerplate is categorically wrong every time. So it's like I have to go fast to massively slow down to find out all the problems where everything's at. And then I can speed up really quick and then I have to stop and like do this thing again, trying to figure out what the hell's happened. Whereas if I just build it myself, I can just be like, brrr, and I just overall am significantly faster.
Bad, functional programming good.
That's why I like logical boilerplate only.
There are certainly times when functional programming is more terse. And terse can be good, but it can also be bad, ultimately depending on how easy the code is to read and understand.
Straw man. Dumb straw man. That's just a dumb straw man. I can minify code and say, look at this. This is terse. See, not all terse is good. That's just a straw man argument. Don't make that argument. You can make much better arguments, right? You can make much, much better arguments than that, right? Really, really well-written Rust feels very confusing to me when I was first starting out because I didn't understand a lot of the concepts. It was very, very terse, and I couldn't quite grasp all the things that were happening. That, on the other hand, totally get that. Right? Just because something's terse does not necessarily mean it's good. But don't use minified code as an example of terse.
The last of the ideas that functional programmers often cite as the real value of functional programming is the advantage of declarative over imperative programming. I've spoken about this before. There are certainly significant advantages to expressing some ideas declaratively. My approach to test-driven development is to always aim to declare in my tests what I want.
That's a good take right there. That's an extremely good take. If you're doing a test and you're doing logic, 95% of the time I'll say you're wrong. If you cannot declaratively state what you are doing, you're probably doing it wrong. Honestly, you're probably doing it wrong. Because once you start putting in heavy amounts of logic, you start needing to test your tests. And once you get to that point, you done up, okay? You up.
The system to do without
Why are you guys
attempting
still talking about terse?
Shut up. Or say how it does it. This means that my tests are a lot more durable to change than tests that attempt to assert the implementation detail in the code. This is the same idea as declarative programming. If we can clearly express the outcome that we'd like to achieve without worrying about how the outcome is achieved, then great. I see lots of examples of this in examples of functional code, but to be honest, it's less obvious in people's real code as far as I can see. To be fair, my exposure to reading other people's functional code is somewhat limited. I don't read lots of it, so this may be down to the limits of my experience, but...
You should state that up front. Because the problem is you've made this whole 20-minute case about why they're the same, and then you kind of just you kind of said the quiet part out loud, which is you don't have a lot of experience on one side. Like, I don't have a lot of experience on one side. I'm definitely not like a hugely functional person. My most functional language is Rust, and that's not like, I wouldn't put that as like, I wouldn't categorize it as like functional, but it has a lot of functional concepts, but still, that doesn't mean I know a lot about it. That's why I can't tell you a well-written OO project can it end the same as a functional project. I don't know. I don't even know.
If this is the case, if the levels of abstraction that functional languages give to us are genuinely as advantageous as functional programmers tell us that they are, then shouldn't functional projects prove to be a lot faster to develop and produce fewer bugs than non-functional?
Again, that's a very hard statement to measure. Once again, so the problem with this statement is that throughout the 90s, 2000s, 2000, and really all the way up to like 2020, it's been largely dominated by a singular thing, which is like largely OO styled languages. And so we don't have like a huge amount of data on is functional better. I don't know if it's better. And I like to think personally that Rust ultimately is better for developing, even long term. I think it makes a much better programming language to develop on than, say, TypeScript. But am I right? I don't have like a huge amount of experience yet to really like say that. Better. So how I think of better is in 6 months, what is the speed of features? In 2 years, what is the speed of features? To me, if you cannot make features in your programs, then that is really what is better or worse. Ultimately, that's for me, that's like the biggest thing. Sure, like performance is obviously very, very important. It's a cornerstone of any good piece of software. But if you, for a long running project, a project that continually has to change, like Twitter, like anything, making a change, if that takes exponentially longer, then something is wrong, right? Like when you go on Twitter, when you go on Twatter over here and you jump in here, let me just find this screenshot I have. Dang it, here, let me just jump in here. I have a screenshot right here. Hey, look, it's me. Look at this. This is the source code for just this tweet that's right here linked. That's the divs and video element for just the tweet itself, not for any comments or anything else, just the tweet. Like, that's an insane amount of stuff. Like, try to make a change to that. Is that a brittle system or is that an easy system? It's a brittle ass system, right? Like when you look at this, oh gosh, I'm in the Firefox. Hey bro, is that Firefox? Dude, let me just zoom in. Hey man, let me just zoom in. Here, let's go like this. Let's do it again. Inspect, right? So when you look at this, you're like, oh gosh, like it can just keep on going. Like you can just look at all that. Look at all that. That's a lot for a div. Can we all agree that that's probably a lot for a div? Or, oh my goodness, dude, I hate Firefox. Don't become emotionally angry. You're gonna make it. Trust me, you're gonna make it. I mean, look at this thing. It still is going. Like, starting right here, look at how many divs there are. Look at that for this thing. Just this one little thing. Just this one little thing right here. What is it? Here, let's go over here and go like this. What is it? It's HTML prettify. HTML prettify. It's just an effing image. It's just an effing image, and this is what we got for an image. Like that's a lot of stuff to generate. It's just a lot. Div slash a div ending div image. All right, that's a lot of stuff, man. Hey man, that's like a lot of stuff. Hey man, that's like your opinion. No, it's just a lot of stuff. Man.
This is the claim that functional programmers sometimes make. But I have looked and I don't find much evidence to support this claim. Functional programming does appear to produce fewer bugs, but the research that I've read says that this is at or close to the level of statistical noise, resulting in about a 1% fewer bug fix commits than imperative languages when measured by comparing the...
I don't like research papers into these kind of things because there's too many factors, right? The thing is, okay, so at Netflix, if you want to get a feature through and you think it can change retention and you think that you've developed something significantly better, it takes millions upon millions of people to test that that's actually true. And the reason being is that the confounding factors, even on a singular change, is insane. Now let's take something like development, where you have various languages, experience with the languages, complexity of the problems they're solving, complexity of the systems that are required to solve, management. Management plays a huge role into all of that kind of stuff, right? Like, just think about how many confounding factors exist in trying to solve this thing. This type of research is what I would call as academic masturbation. It's useless.
Ratio of commits that are for new things versus commits that are intended to fix bugs. To put this into context, the data for unit testing says that you get somewhere around 58% reduction in production defects overall, though measured in a completely different way. So it may not be fair for me to make this comparison. But
it's never fair to make those comparisons, okay? No. I don't know if unit testing gives you anything. It could give you a lot. It could give you 90%. It could give you 0%. Again! Go!
But the difference, if any, in the quality of the code produced by functional programming versus object-oriented programming languages seems to be tiny. I think that both functional programming and object orientation are valuable tools, But I also think that there are some extravagant claims made for functional programming in particular, that to me at least don't seem to stand up to scrutiny. My conclusion is that
I don't think you gave us a solid scrutinizing take here. You know, relying on research, I think, is just too fraught with confounding factors. Saying that you didn't have a ton of experience doing it. I would take somebody's opinion. Like if Pick came in here, where's Piccadilly at? If Piccadilly's in here and he says, hey, I really think these things about it, I'd actually take his word a little bit higher because he's been doing Haskell for years and he's done other languages as well. Like he at least has enough experience somewhere to kind of give somewhat of a weighting. Like I need to see someone with a lot of experience building a lot of applications, right? Haskell,
that it pays to understand both functional programming and object-oriented programming. The idea that functional programming is a step beyond object orientation in the evolution of programming languages seems just a complete misinterpretation of the history and of what's going on in reality. OO and FP are both valuable tools for building complex systems. Use them in the right context, and each will help you to build better systems, but neither is the deciding factor. Thank you very much for watching, and if you enjoy my stuff, please do consider supporting our work on this channel by joining our Patreon community. There's a link in the description below. Thank you.
Sound equalization, please. I did not choose this photo. I kind of feel like I gotta go, yo, what is this photo? I need like a little monocle. I need one of those Gaucho Man mustaches going on here. I need like a top hat. Dude, this is not me. This is not me. I can tell you that right now, okay? I learned nothing in that video. Yeah, okay, so takeaway from the video is that the title did not promise what it delivered. Meaning I didn't learn when to use functional versus OOP. I really didn't learn the difference between the two. I'm coming away more confused than I was in general on that topic, because I really do want to understand when I do want more experience in functional programming, because I want to actually have like a really strong opinion about it, because right now I'm just like a Rust Andy, right? Oh, what did you build? Hey, build it in Rust. Oh, what's that over there? Did you try it with Rust? Right? Like maybe I need a little bit more, you know what I mean? Maybe I need a little bit more, but I feel like I don't, and I don't know what I'm doing, okay? Hey, the name is the Primeagen.